standard VDA. They have a deep compression V2 encoder. You might remember it as the super codec. It was introduced with ZenDesktop 7. And, well, I don't know how obvious it is from the back of the room, but especially the red text, the contrast, is, well, quite fluffy. You can see it here when we magnify it even further, that the red is not the same color. The contrast is, well, quite different. And that is because the H.264 is a motion-based algorithm. It's supposed to throw away data which we as humans and our brains either can't comprehend or can make pieces of the missing information. So it throws away a lot of data, but unfortunately in still picture scenario or in text scenario, high contrast scenarios, it's not that great. So the users, the first test users, were using this one in looking at text 8 hours a day with this fluffiness. Of course they wanted to have a clear image. Yeah. So it was of no use. So moving to the standard VDA and the deep compression V2 encoder, it became, well, very much better. As you can see from this, the policies have been tuned quite a lot. So we have a session bandwidth limit of only 3 megabit with the standard video, as opposed to the 50 megabit in which we hit the roof with the HDX3 Pro and the lossless before. Of course, the frame rate has been lowered a little because, well, it's always a trade-off between bandwidth and, of course, frame rate, resolution, and so on. And this being office workers, of course, the focus had to be on being able to read the text before having a fluid video and so on. And, well, I'm not sure how many would watch a movie in their desktop session. Of course, you should never say never, but then their managers should go and talk to them. And, well, the video quality was also limited to save some bandwidth. And it's with the default medium picture quality. Some other optimizations, of course, was to go away from the audio quality being high quality, but going down to medium and optimized for the voice over IP because of the Skype for Business. And, well, you know the other ones. A funny one, they're using Imprivator. How many knows Imprivator? Ah, okay. Imprivator has, as it is a municipal, they have some information that not everybody are supposed to watch. So if a user should leave their workstation and forget to lock their workstation, then after a given time it fades into light gray, then after a given time it fades into black, dark gray, and then it fades into black. It does this in 3 steps, but of course it's an animation. So this animation just eats the bandwidth again. By no other means, nobody's watching this animation. So I asked the Imprivator guys, why do you do a flow in the color? Why just do a direct instead? Oh, but why? Yeah. You can see here they're utilizing all the bandwidth just by doing this, and nobody's watching anyway. So, well, that was a curious one. So I got the opportunity to test this environment a little further to see what other benefits did it get. I wanted to test the environment which resembled the user's environment, but still in which I had control, and where I could define what was to be changed, what was to be tested, of course. And I was given a virtual machine, and well, this virtual machine, though being non-consistent, I made a delivery group, so it was only me who was able to access it, and I could control it a little bit better. Because it was a production environment, so of course I couldn't do changes which would affect everyone, but myself. There were some factors which I couldn't control either because of the nature of it being a production environment. In the office hours, of course, a lot of users were on, resources being used. So I primarily did these tests in the evenings and in the weekends because there weren't that many users utilizing background jobs, antivirus scannings and so on, which I couldn't control either. I didn't see them affected, but it might have been an effect, could have been. But I didn't see anything that could relate to it, but still. So when we want to test, of course we want to control the changes. We want to be able to pinpoint that it's this difference that is equal to this result. We have to repeat the behavior. And as I said before, not every factor was in my control, unfortunately, so I did multiple runs and maybe more than I needed to, but just to be sure that the statistical data was, well, at least pointing in a direction. And we're doing these because of the vGPU structure, that it's time slicing. You can have the noisy neighbor, you can have other VMs affecting the physical GPU. I was making certain before every run that my VM was the only VM on that particular physical GPU, as to not at least isolate my own virtual machine and not being affected by other VMs on that physical GPU. The environment was conducted in an IP session, full screen. It's a desktop 7.8 standard VDA. We went all the way away from the HDX3D Pro because of these problems with the clarity of the text, and receiver 4.5, of course. I had 4 scenarios I wanted to test. In this case, no GPU and hardware acceleration off for Office. And yeah, you can see them all there. I was using a script to automate it. The script initialized the variable if we were to have hardware acceleration on or off. Of course, I had to control on the lower layer if the vGPU should be available or not. The script also executed the behavior, and I did monitor through perfmon on specific counters, but only when the process was running, so as to not get results which could manipulate the result. So whenever work was running, of course I was monitoring, but I wasn't putting a 0 value when it was not running. So I tried to be sure to secure the data was only for that period of time when the specific process was running. And well, as I'm not good at scripting, I relied on a benchmark program called PCMark 8 to do the user behavior. Instead of me using 30 times as long as I already have on learning how to script word behavior in Excel and PowerPoint and so on, I relied on the PCMark 8 to run in the background and to mimic the user behavior. What it does is, in Word, it's creating a document, it's writing, typing a lot of stuff, putting some images in it, resizing images, and normal user stuff. The Excel is importing a data set into Excel, doing some calculations and turning these calculations into some graphs, as you can see. And PowerPoint is creating a PowerPoint slide, also creating new slides, resizing the images and fitting it onto the slides. So what I would say is a normal user, could be a normal user behavior, but it's in a scripted way, so it's repeatable. And each run consists of 3 of these sequences and 10 runs with a reboot, 5 runs, and then a reboot, and then 5 more runs of this. So I had a minimum of 30 times for each Office application to pick out data, and we had the 4 scenarios, so approximately 120 times for each Office application. Well, I have spent quite a lot of time and energy on this, and again, me not being a scripting dude, so that took a lot of time. Got a data, and the result, as you see here, is Office 2013, the average process load for the given. You have the blue with the no GPU hardware acceleration on and the hardware acceleration off, the next column. And of course you have with GPU with the green ones, hardware acceleration off and hardware acceleration on. And I couldn't quite see any difference. Well, there's a little with Windward, but again, 3% point could be, well, statistical insecurity, I don't know. And as you can see there are some, on the TTX GFX process, you can see some behavior. So something is happening on the screen, it's not just a blank screen that I've collected data from. But the final CPU load is lowered, and that was, at first, I had this one with, so I did some more monitoring and I found out, oh, I mustn't say that, and then I had to do all the reruns again with this instead, so well, I learned something. But this is the average process load, going to the maximum process load, which is, well, more interesting when we are talking about sizing and talking about the worst case scenarios. Of course, the CPU is maxed out, that's supposed, but we start to see differences here in the different processes, especially here. I'll deep dive a little into that later. I also did some testing of YouTube. It was done in a windowed environment, not a full screen, because the most users I have seen when using YouTube hasn't been full screen. Of course, it looks great in full screen, but they have either they have it put to the side and then they have their Skype for Business, or they have a document they're working on or something. So I don't see that many using full screen YouTube actually. So trying to mimic that, also the same testing environment. Yeah, some things to note is that when we are windowing the YouTube, then the flash is forced to software rendering instead of hardware rendering. So, well, I believe that would mimic a user behavior more. Again, the test sequence executed by the POS scripting. It was a 5-minute video, and I can give you the link if you want to test yourself. And again, the perfmon counters was done on specifically processes on the Internet Explorer process and the other processes as well. Only this time it was time fixed, whereas before it was controlling each time when the process was running. And this time I did 15 runs for each scenario, and again 4 scenarios with and without hardware rendering, with and without GPU. So the average CPU load, well, I can't say that I can explain why there's no difference between hardware and software rendering in the Internet Explorer. Again, we see the CPU load being quite offloaded in the average, and, well, as you already can see here, it's the DWM process. Going to the maximum CPU load, it becomes even more obvious. Now we start to see differences between hardware and software rendering in the Internet Explorer scenarios, and even more significant increase in CPU load. So what is the DWM process? Yeah, it's a desktop Windows manager, and it was introduced with the Vista, with the Arrow user interface. And well, as soon as we in a setup environment try to mimic the Windows 7 look and feel with the desktop experience, then we get a DWM exit process. And of course, based on DirectX, it is utilizing the graphics, the GPU. And I had thought that I would see a larger difference between having Office hardware accelerated or not from the application. When actually it was at a lower layer, we do see the benefits. So diving a little into this and putting all the numbers beside each other, you can see, of course, when sizing, you would size for the CPU load in the maximum case, and you see well, 1 to 2.5 from the worst case to the best case. Now, this may not seem as the best case scenario, but looking at the average CPU load, you can see that it's quite significant decrease we have in the usage of the CPU. And this pointing to that we are having spikes, but the average is lower. And this average might be higher, but doesn't have that big high spikes. So, yeah. Why it is like that in Office, I don't know. For the YouTube, also quite significant increase when having a graphics accelerator beneath Windows to support the rendering. And yeah, I think the numbers speak for themselves. Yes?
Yes, I have a question about the max CPU load. Is that if there is one spike to 30% in the whole scenario, then you measure the 31%?
Yeah.
Okay.
Yeah, but not how many times it's maxed or something. It's only the maximum spike.
What kind of interval did you use to measure the counters? Is it the 1 second interval?
Yeah, 1 second interval in per month. So there could be hidden spikes as well, or there could be hidden lows, of course. So this could be more precise, of course, but given the tools I had available. So this was Office, creation of documents. It was YouTube. I also did a testing of PowerPoint slideshow, like I'm doing now, and how it is affected by the GPU. And as you can see, well, without a GPU and with the GPU, it's not as granulated as the previous benchmark. Actually, this is an older benchmark. It's done in the same environment, but also a quite large increase when having a GPU in the Desktop 7 session. I have to speed up a little. There's more. Because we're using, or talking about the H.264 encoding, we also have some decoding. The grid cards can do some decoding of video they collect from the internet, and they can do some offloading on the encoding when sending it to the endpoint devices. And of course, the endpoint devices has to be able to accumulate or to process all this data that is delivered to them. So having a full screen YouTube on my computer here, I did some, well, unscientifically tests, but as you can see here, average CPU load and max CPU load on my local machine when having a GPU to help, and when not having a GPU is also quite significant. Now it may not, you may say that, oh, you have a lot of cores and you don't have other resources. Well, but I want that snappy feel. So the more the CPU can be offloaded, the more snappy feel I will get. So, as I said a couple of times, the next steps in this environment would be, of course, Sensori 7 and Desktop 7.11 with the NVENC, but NVENC is H.264 full screen only. So we have to go back to the HDX 3D Pro and to do some testing, but I will definitely test it. And another thing on the 7.11 is that they have this new adaptive display protocol V2 and a development of the deep compression V2 encoder. So it will be very interesting to see, and I hope to do a presentation on this another time, of course, with Windows 10 being way more relevant than Windows 7. But so key takeaways for this session: if you just woke up, you can help your applications by delivering the resources which they need, and that GPUs are not just for high-end users. And it's just not just rendering, but also encoding and decoding you have to take into account. Any questions? Oh, there was one in the back.
Can you remind me the name of the application you use for load testing?
For load testing?
Yeah.
The PC Mark 8. It's the same company which uses or makes 3D Mark, if that rings a bell.
Okay.
Yeah.
Which endpoint device were used?
Oh, I forgot to mention, on the customer they had a lot of thin clients actually. So the thin clients were able to do hardware offloading of the H.264 stream. They have a dedicated chip on board, so that was yeah, good way.
What sort of
Dell-wise, D10D, I think it was called. A zero client.
And were they Windows or Linux?
Linux. Zero. Oh.
Yeah. In the next step, you mentioned Windows 10, but what about the Office version?
That would probably be 2016.
Because that has an even higher GPU
Yeah,
need.
yeah. So. Oh, but I think we already went to the Q&A. Were they? Yep.
Did you run that PC Mark tool? Was it for the tool for the load testing? I forgot
Yeah,
the name of it.
PC Mark 8.
Yeah. You run that in one session, or did you do with multiple sessions at one time?
I did both. I did, of course, the first test sequence, and I did 5 of those. Then I rebooted the machine and then started all over again.
Okay.
But of course, collecting the data.
Yeah, okay, but it was one concurrent session
Yeah.
each time. So
Yeah.
not multiple sessions on one host running the.
No, it was just one session. Yeah, one more.
What was the decision around using that tool versus logging VSI? Is it functionality, price?
It was well. It was
Budget.
in a lack of me having the available to script some word sequences. It was the easiest way for me to find a way to do something that would mimic a user behavior. I haven't, unfortunately, that much experience with the login VSI, so
Right, which is your choice.
yeah.
Yeah, okay.
And he was also testing just a single.
Yeah, single session.
Logging BSI is more of a multi-user loading.
Yes.
How was the scaling of the server? So you have said you have 2 cards per server? Or?
Yeah, 2 Crit K1 cards. Each card are able to sustain 32 VMs, so that's yeah,
64
up
VMs.
to 64 VMs per server
This was the scaling, 64
Yeah.
VMs
per host.
per host.
Yes.
If you hadn't had GPUs, what sort of scaling do you think you would have got?
If I had that.
If you didn't have GPUs, what sort of scaling do you think you would have got?
Interesting question. I think
It's just like, that's the kind of question a customer will ask, like,
exactly.
so I was just wondering if you had any information around that.
No, I don't quite. But my best guess is that the customer would have the same scaling, but they would just tell the users to, well, you just have to live with this lower user experience.
Yeah.
Does the GPU profile you used corresponds to the lowest GPU profile of the M10 now?
Yeah, it does, but the M10 architecture is way faster than the K1, so of course, and the M10 is able to sustain twice the amount. I will be careful to do a one-to-one correlation of these 2 cards, but it is the lowest possible profile. And of course, in the M10 scenario, they could save 1 K1 card, and then just one M10 could sustain these 64 VMs. Actually, they could have up to 128 VMs, but then I think we're hitting another barrier with the CPU logical number, of course.
And you were only measuring CPU. Were you also measuring other counters like latency or UI behavior or something?
No, this was CPU offload only.
But why were you just interested in the CPU?
Because
you could just have in more CPUs and save the money on the graphic card.
Yeah, you could, but some applications require GPU, I'm afraid to say. Especially when you're talking web-based. I was at a customers who they have already decided to implement Salesforce, and in Xena it runs like crap. One user is able to utilize, on average, 33% of that current Xena server, and spiking at 50%. And that's because Salesforce are using all these menus, all these flowing animations and so on. You can trim the GUI, the lighting experience they actually call it, but it's not lighting at all when you don't have a GPU. You can trim it and it becomes better, but never gets as good as when you're having a GPU. Another example
is not just for Office, you also did it for other applications now.
I only tested Office and of
just
course
tested Office, but you're using other apps which use GPU then.
Yeah,
Okay,
yeah.
all right.
And in one of the slides I showed that the DVM process actually is sitting on top of Windows Presentation Foundation, which is from .NET 3. So as long as your application is based on .NET 3, then it's also utilizing indirectly the graphics acceleration. So it's not just for heavy users anymore. I think everybody can benefit from this. But feel free to connect on LinkedIn and Twitter as well, if we're not already.
Well, you must connect on LinkedIn.